Hello again, Mr. Boothman here. We're going to be talking about section 5.3 today. This is all about right triangle trigonometry. So this, again, should be pretty familiar from geometry, whether that was last year, the year before, more than that. I'll refresh your memory, and hopefully this section shouldn't be too difficult for us. So let's get started. So if you'll recall from section 5.2, we asked the question, what happens when an angle does not occur on the unit circle? When it's not one of those special points, 30 degrees or 150 degrees or 315 degrees, what happens then? And we found that if we could add or subtract 2 pi to get one of those special angles, then we could do that. We can use that to get an angle that we recognize and then evaluate the trig function from there. Otherwise, if it's not just a matter of adding or subtracting the period, like if I want the cosine of 101 degrees, for instance, then I'm going to have to use a calculator. Okay, I know you're so excited you get to use a calculator. I'm telling you to use a calculator. I'm telling you there is no other method that we're going to need to know except using a calculator for this in particular. Be grateful that you have a calculator. I know some other teachers in the math department who, shall we say, did not take high school math recently, did not have the luxury of using a calculator for this. They had to use trig tables in their textbook that gave them the answer. They'd have to look up the angle that they wanted and then the trig function that they wanted. So you have a calculator. That's awesome. Let's use them. Now, the one thing to be careful with using the calculator is you have to make sure that you're using the right unit when you plug in an angle for a trig function in your calculator. Okay, to do that on your TI-84, you'll press Mode and then scroll down to where it says Degree and Radian. You're going to highlight the one that you want and then press Enter. And then you can clear back out of that and then go ahead and do what you need to do. But make sure that you're in the right unit. The cosine of 101 degrees is very different from the cosine of 101 radians. And your calculator will calculate whatever mode it's in. So please, I guarantee someone makes a mistake like this on a test or a quiz. Do not be that person. Check your mode. All right. So let's take a look. Use a calculator to evaluate each function value. If I see the degree symbol here, then I'm in degrees. If I don't see it, then I'm in radians. So for example 1, these 6 problems, it looks like I'm in degrees for all of them. You're going to do letter D on your own. But the rest, we're just going to make sure we're in degree mode. And once we are, it's just plugging it in. Cosine of 101 degrees. Here I'm going to ask you to round to 2 decimal places. We will always specify what we want you to round to. So I went on ahead and plugged all of these in beforehand so that you wouldn't have to sit here and wait for me to do that. Okay, so here are those answers. And again, rounding to 2 decimal places. Those were all in degrees. So for example 2, we are in radians. So I'm going to make sure that I change my mode from degrees to radians if I want the correct answer. Maybe you don't want the correct answer. I guess it's your choice. You're again going to do letter D. But once I make sure I am in radian mode, then I'm just plugging it in the same way. So hopefully you know where the pi is in your calculator. If you don't, it is second and then the little caret symbol right below clear, I believe. I'll pull out my calculator to make sure I know what I'm talking about. Yes, right below clear, there's a little caret button. It is second, that button. That'll give you pi. And then you can go ahead and just plug in sine of 8 pi over 5. And again, I'm rounding to 2 decimal places, and I did this beforehand. Oops. Didn't mean to skip ahead quite that far. Okay. One thing to be absolutely clear about for using a calculator for evaluating trig functions like this is that if you have a special angle, if I ask you for the sine of 30 degrees, or actually cosine of 30 degrees would be a better example. The cosine of 30 degrees, we know from the unit circle, is the square root of 3 over 2. Okay, the square root of 3 over 2. The square root of 3 over 2, if I plug in, if I ask my calculator cosine of 30 degrees, it is not going to give me the square root of 3 over 2. It is going to give me the decimal approximation for that. And some of us, I know, think, oh, that's fine. I can take that decimal and I'll change it to a fraction in my calculator. When you try to do that, your calculator will give you the decimal again. No matter how many times you try it will leave it as a decimal. Your calculator won't give you that fraction because it has a square root in it. Your calculator doesn't like giving square roots like that. So it'll just keep giving you the decimal. It'll assume that's what's most useful to you. So if I ask you for the cosine of 30 degrees and you give me the decimal approximation, I'll know that you just used your calculator. That's wrong. It's also not an exact answer. I want an exact answer for that. The cosine of 30 degrees is the square root of 3 over 2. Okay, so make sure that if it's one of our special points on the unit circle, that you are using that point. You tell me that the cosine of 45 degrees is the square root of 2 over 2. Cosine of 30 degrees is the square root of 3 over 2. Okay? That's why we still need to know the unit circle, even though we do have our calculator with us. All right, enough about that. Just a bit of a warning for you. Let's move on to the meat of this section, right triangle trigonometry. So we're going to look at this example. I'm going to have you do letter C on your own. Find the value of the 6 trig functions of the given angle theta. So they gave us a right triangle. They gave us the angle here, theta. They filled in most of the triangle for us. 3 and 4 are the lengths of the legs. But I want the 6 trig functions. So the sine of theta, that's opposite, which is 3 over hypotenuse. I don't know the hypotenuse. Again, going back to geometry, how can I find the hypotenuse? I know 2 sides of the triangle. I can use the Pythagorean theorem, a squared plus b squared equals c squared. So here, 3 squared plus 4 squared equals x squared. And this gives me x equals 5. 3, 4, 5, special right triangle. Hopefully this does not look too foreign to you. So the sine of theta is opposite 3 over the hypotenuse, which is 5. Cosine of theta is adjacent over hypotenuse. Tangent is opposite, which is 3, over adjacent, which is 4. And then the other 3 are just the reciprocals of these. So cosecant is the reciprocal of sine. Flip 3 over 5, and I get 5 over 3. Secant is the reciprocal of cosine, 5 over 4. Cotangent is the reciprocal of tangent, so 4 over 3. Notice that I don't need to know what theta is to evaluate these trig functions, since they're just ratios, and I know the lengths of the sides of the triangle. Okay, let's look at letter B. Here they gave 2 sides again. I know I'm going to need to find the final side. So 2 squared plus x squared in this case, it's one of the legs, equals, sorry about that, equals 6 squared. So 4 plus x squared equals 36. X squared equals 32. Take the square root of both sides. X equals the square root of 32. And then I can simplify that. X equals the square root of 16 times the square root of 2, which is 4 times the square root of 2. It's a 16 in there. Time. Okay, so x equals 4 times the square root of 2. I don't have a lot of time to go into explaining how to simplify radicals like that. If you are not comfortable with that, please do come ask me. I can give you practice and I can explain it much more clearly in person, okay? But I don't want to make this a 30-minute long video again, so I'm doing my best. Because I know no one likes watching a 30-minute long video. All right, sine of theta is opposite over hypotenuse. Simplifies to 1/3. Cosine of theta is adjacent over hypotenuse, and I can simplify that to radical 2 over 3. Tangent of theta is opposite over adjacent, and then I can cancel 2, numerator, denominator, give me that. And then I can rationalize the denominator, and that's what it simplifies to. And then the other 3 are just these flipped. So 3 over 2 radical 2, rationalize the denominator, and I get this, and then cotangent 4 over radical 2. Rationalized is 2 times the square root of 2. Okay. Again, try letter C on your own. I'm going to do letter D for us now. Here I need the hypotenuse again, so this is 3 squared plus 3 squared equals x squared equals 9 plus 9, which is 18. So x is the square root of 18, which is the square root of 9 times the square root of 2, or 3 times the square root of 2. Okay, so the sine is opposite, which is 3 over hypotenuse, 3 square root of 2. The 3's cancel, and then I can rationalize the denominator. Square root of 2 over 2. Cosine, it's going to end up being the same thing since I have 3 and 3, same side lengths. Tangent, y over x, sine over cosine. That is just going to be 1. Cosecant of theta, that is going to be sine flipped, rationalize the denominator. Secant is the same since cosine is the same as sine in this case. And cotangent, if I take the reciprocal of 1, I get 1. Okay. All right. If you do have questions, please let me know. Write your questions down. Come see me and Miss Parker. All right. So for example 4, you're going to be doing letter D on your own. I'm going to go through the other 3/4 now, though. So sketch the triangle. So this time they didn't give us the triangle, but they did give us enough information to figure out what the triangle is. Okay, so here's theta. And the sine is 3 over 4. Sine is opposite over hypotenuse. So they ended up giving me exactly what I needed. Figure out what this final third side length is. 3 squared plus x squared equals 4 squared. X ends up being the square root of 7. Okay, I know I skipped a bunch of steps there, but it's algebra. Hopefully you see how I got there. Come talk to me if you don't. Okay. So they gave me the sine. Cosine of theta, adjacent over hypotenuse. Tangent of theta is the opposite over adjacent, so 3 over the square root of 7. Rationalize the denominator, and that's what I get. Cosecant, going to need to flip sine, 4 over 3. Secant, flip cosine, 4 over the square root of 7, which is 4 square root of 7 over 7. Cotangent, flip tangent, so square root of 7 over 3. Okay. Really, the hardest part about problems like this is just the setup. Once you can set up the triangle, it shouldn't be too bad. Secant, this is the reciprocal of cosine. So cosine is adjacent over hypotenuse. If secant is the reciprocal, then that means the secant is hypotenuse over adjacent. So what's my denominator here? Well, there's an invisible 1. Hypotenuse then is 2, and then the adjacent side is 1. So what does x end up being? 1 squared plus x squared equals 2 squared. X is the square root of 3. All right, so knowing that, we can figure out the rest of our trig functions. Sine of theta, opposite over hypotenuse, cosine of theta, adjacent over hypotenuse, tangent of theta, opposite over adjacent. Look at that. These values should be familiar to us. This is, in fact, 30, 60, 90 triangle. Cosecant of theta, that is going to be the reciprocal of sine, and then once I rationalize that denominator, and then they gave us secant, cotangent, 1 over the square root of 3, square root of 3 over 3, when I rationalize it. Okay, let's do letter C, our last one. Cosecant, reciprocal of sine, so it's going to be, instead of opposite over hypotenuse, it'll be the hypotenuse over the opposite side. So hypotenuse is 3, opposite side is 1. I need to figure out what x is. 1 squared plus x squared is 3 squared. X is the square root of 8, or 2 square root of 2. Again, I know I'm going a little fast now, but Hopefully you've seen enough examples at this point that you're comfortable. So the sine of theta is 1/3. Cosine of theta, 2 square root of 2 over 3. The tangent of theta is the opposite over adjacent side. Rationalize the denominator, as always. They gave me cosecant, so I need secant. Secant means I flip the cosine. Rationalize. And then cotangent, I flip the tangent, 4 over square root of 2, which ends up being 2 square root of 2. Okay? All right. Hopefully you're still with me. If you need a bit of a pause going ahead, we're jumping to the last page of this section. And it's word problems, applications, which I'm so excited for. I know you are, at least I hope you are. We're going to start with example 5. And this is kind of easing us into a topic that we'll cover much more in depth later this unit. But for now, we're just going to kind of start thinking about this and using a calculator. Find the values of theta in degrees and radians using a calculator. So they said the sine of theta is 0.0145. And I want to know what theta is. Okay. Remember that sine is a function. So if I said f of x equals some number, and I wanted to know what x was, how do we undo the function? How do I undo a function? If you'll remember, go all the way back to Unit 1 this year. We talked about the inverse of a function. The inverse undoes the function. So in this case, I need to undo the sine function. I'll need the inverse of the sine function. And in your calculator, there's a button. It is second and then sine. And it looks like this. We have sine and then there's a little -1 above it. Now, that's not saying we're raising it to the -1 power. That's also not saying it's like 1 over sine. So we're going to, again, talk about that distinction later this unit. But for now, we're just kind of easing our way in and thinking about this. So sine of theta equals 0.0145. If I want to know what theta is, then I just go into my calculator and I press second sine, so the inverse sine of this number. Plug it in. Okay. Now, whatever mode you are in is the mode your answer, the calculator gives you, will be in. So if I'm in degree mode and I do inverse sine of 0.0145, it's going to give me 0.83 degrees. And then I can either use my conversion factor to change that to radians, or do the same problem in the calculator but change my mode to radians, and it'll give me 0.01 radians. Okay, go ahead and try letter C on your own, but I'm going to finish up B and D. So same thing here. Theta is 27.6 degrees, about, or 0.47 radians. And then letter D, went on ahead and did these beforehand again. 66.99 degrees, or 1.17 radians. Okay? So, again, shouldn't be too difficult using our calculator. We'll talk way more about that later. But for now, I do want to get to our word problems. And I promise you hear word problems, you're probably freaking out. It's not that bad. It is not that bad. A surveyor is standing 115 feet from the base of the Washington Monument. The surveyor measures the angle of elevation to the top of the monument as 78.3 degrees. How tall is the Washington Monument? Okay, so for these word problems, there's two things we need to say beforehand. First, angle of elevation. So the angle of elevation, suppose this is where the person is, and he's looking straight ahead. Okay. Angle of elevation is this angle right here, angle of elevation. So from looking straight ahead, and then however far up I have to look, that is the angle of elevation. Now, none of these problems talk about this, but we can also talk about if I'm looking straight ahead and then I'm measuring the angle down, that is what I call the angle of depression. Okay, angle of elevation, angle of depression. Second thing I need to say about these problems, these word problems, is that you should always, always, always draw a picture. The picture will help you so much. It'll help you visualize what's going on, and it'll help you set up the triangle that we need to be able to use trig to solve these. Okay, so a surveyor is standing here, and he's 115 feet away from the Washington Monument. So here's a Washington Monument. It's 115 feet away. And the angle of elevation, so he's standing here, he's looking straight ahead, and then he's looking up. So the angle of elevation is 78.3 degrees. If he's looking up to the top of the Washington Monument. Okay? And he wants to know how tall the Washington Monument is. So that'll be this side length. We'll call that x. Or you can call it h for height or w for Washington Monument, whatever you'd like. And so I have a right triangle here. And I have an angle here, and I know the opposite side and the adjacent side. So I'm looking at tangent. So the tangent of this angle, 78.3 degrees, is the opposite side over the adjacent side. So if I solve for x is 115 feet times tangent 78.3 degrees. Plug all that into a calculator, and I get that x is about 555.31 feet. That's how tall the Washington Monument is, according to this surveyor. See, I told you it wasn't that bad. So long as we set up our picture, it's just using simple trig. Okay, so let's take a look at number 7. An historic lighthouse is 200 yards from a bike path along the edge of a lake. A walkway to the lighthouse is 400 yards long. Find the acute angle theta between the bike path and the walkway. All right. If you're like me, you read this problem and you're trying to picture what on earth is where are these things? I had to reread this a few times. I don't think this is a very well worded question. This was taken, I believe, from a textbook, the pre-calculus textbook. On an assessment, on a problem I write, I would definitely be a lot more clear about exactly where these things are, because this is a little ambiguous. But rest assured, we can figure this out. We have a lighthouse, an historic lighthouse, in fact, and it's 200 yards away from this bike path. Okay, so we have a bike path going by here. Now there's a walkway from the bike path to the lighthouse that's 400 yards long. Why they wouldn't just build it as 200 yards, the shortest route possible, I don't know. But there is this walkway here, 400 yards long. And we want to find the acute angle. Remember, acute is less than... God, I'm sorry. Acute angle is the opposite of obtuse. It is a small angle. We want the acute angle here between the bike path here and the walkway. Okay. And I have the angle here, I have the opposite side, and I have the hypotenuse. So I'm looking at sine of theta equals 200 yards over 400 yards. And yards cancels out. 200 over 400, that all reduces to 1/2. The sine of theta is 1/2. Where is the sine of theta? 1/2. Look at our unit circle. It is actually equal to 1/2 in 2 different quadrants. So the sine of theta is 1/2. Sine, remember, is y. It'll be 1/2 at both 30 degrees and at 150 degrees. Now this angle, it's less than 90. It has to be. We're in a triangle here, a right triangle. So I can ignore the 150 degrees, and the sine of theta is 1/2 at 30 degrees. So the acute angle in there is 30 degrees. Okay. Go ahead and try example 8 on your own. It shouldn't be too bad. But I'm going to do example 9 for us here. Last problem in this section. I did my very best to keep this from getting too long. I do apologize. A surveyor is standing 50 feet from the base of a long tree. So here's my tree. The surveyor is standing 50 feet away. Right here. I don't like the way I drew this picture. It's hard to see. 50 feet there. The surveyor measures the angle of elevation. So from here, looking up, the angle of elevation is 71.5 degrees. How tall is the tree? What is this side length? I have the angle, I have the opposite over the adjacent side, so I'm going to look at the tangent of 71.5 equals opposite over adjacent. This problem is exactly like example 6, where when I solve for x, I'm going to have 50 feet times the tangent of 71.5 degrees. Plug all that into a calculator, and I'll get about 149.43 feet tall. Okay. I'm so glad we finally got to some applications of trig. Please let me know if you have any questions or concerns, me or Ms. Parker. Do the problems that I circled here, that are circled in your guided notes, so that you get that practice and you feel comfortable with this. Rewatch anything that you just were totally confused or lost for, and come ready to class. We're going to practice a lot. So have a great day. Thank you so much.